Welcome back. Today we will completely understand Newton's second law of motion, from the basic idea to formulas and real-life applications. What does force do? When an external force acts on an object, it can change the object's motion. In other words, force can produce acceleration. An object accelerates whenever its velocity changes. A force is what causes that change in velocity. Usually, more than one force acts on an object. The combined effect of all these forces is called the net force. When forces are balanced, the net force is zero. Therefore, the object has no acceleration. When forces are unbalanced, the net force is not zero, so the object accelerates in the direction of the net force. Newton's second law tells us that the net force on an object equals its mass multiplied by its acceleration. F equals ma. Here, F represents the net force acting on the object. It is measured in the SI unit called the Newton. Mass represents the amount of matter in an object. It determines how strongly it resists acceleration. Acceleration tells us how quickly velocity changes with time. Its SI unit is meters per second squared. For a constant mass, acceleration is directly proportional to net force. Double the net force, and acceleration doubles. Similarly, if the net force is tripled while mass remains constant, the acceleration also becomes 3 times greater. For a constant force, acceleration is inversely proportional to mass. Greater mass means smaller acceleration. If the force remains constant and the mass is doubled, the acceleration becomes half as large. Combining these relationships gives acceleration proportional to force divided by mass, which leads directly to Newton's second law. From F equals ma, we can calculate acceleration using F divided by m, or calculate mass using F divided by acceleration. 1 Newton is the force required to give a 1 kilogram mass an acceleration of 1 meter per second squared. Newton's second law can be clearly observed whenever a force causes an object to accelerate. With the same force, object accelerates more, while a heavier object accelerates less. If the mass stays constant, increasing the net force produces a greater acceleration. A rocket is another powerful example. Increasing the net upward force produces greater acceleration. When the net driving force on a car increases, its acceleration increases according to Newton's second law.
A football also demonstrates the law. A stronger kick produces greater acceleration when the mass is unchanged.
Remember that acceleration depends on net force, so opposing forces such as friction must also be considered. Newton's second law connects 3 important quantities: force, mass, and acceleration. Newton's second law tells us that net force equals mass multiplied by acceleration. This explains how forces change motion.